we can use logarithms to figure out how long it would take us to double or triple our money in different investment scenarios. So I've gone ahead and already written out my financial model over here. If you need help figuring out how I wrote this, I have a previous video that you could watch about how to do that. Notice what I've done too. For doubling my money, I've just put a 2 in front over here, and I'm starting with $1. Turns out it doesn't matter how much money you start with, the time it takes to double will always be the same. So let's just use 1 and 2, although if you want to try to use 100 and 200, do your first step of the problem and you'll see why it doesn't really matter. We'll just use 1 and 2 to double our money. So I want to go ahead and solve this equation. So I think what I'll do is simplify what's in the parentheses. So adding 1 plus 0.0375 over 4 gets me 1.009375. Now sometimes we round to like 1 or 2 decimal places. For these, we need to be very accurate because you'll notice your first few decimal places, if you round off, it's just going to be 1 or 1.01, and that's going to significantly throw off my answer. So use the full number when you're doing these problems. Now to get rid of that base, just like I always get rid of a base, let's do a logarithm to both sides. The log I'll need to do is log base 1.009375, that whole thing. And once again, I'm going to do that to both sides, so I won't write the whole thing out, but I'm doing the same logarithm to both sides. When I do the same log base of the base I have, all that cancels out and leaves behind just 4t. Now over here I can use a calculator to evaluate this part of the problem, either using the log base button or the change of base formula, but this side works out to be about 74.28. Now remember, use as many decimal places as you can. I'm going to round off what I write down. However, in my calculator I would probably leave that full number so that when I divide by 4 I can be as accurate as possible. So when I do that, it turns out that the time it will take to double my money is approximately 18.57 years to do that. And if you want to check your answer, go ahead and pick any dollar amount that you want to start with. Plug that dollar amount back into this formula using 18.57 years, and you'll see that no matter what number you start with, you'll always double your money. We'll do something very similar in our second example. This time I want to triple my money, so I'm going to use that 1 as my initial investment and then 3 as my final investment to triple that. And then this time I'm doing a problem where my interest is being compounded continuously. So again, I've already started with the model. If you need help getting this set up or seeing where all these numbers came from, go back and watch a previous video about continuously compounded interest. So to do this problem, well, I can pretty much ignore that 1 in front. I need to get rid of the base of e. Well, to do that, I'm going to take the natural log of both sides of my problem to start. So using a calculator, the natural log of 3 comes out to be about 1.0986. Remember, use all the decimal places you can for this. On the other side of the equation, the natural log of e just cancels out, leaving behind 0.0615t, and then finally dividing by 0.0165. I get a time that it would take me to triple my money of approximately 17.86 years. And once again, if you want to check this problem for yourself, go ahead and pick any value, any dollar amount you want to start with, plug it back into your financial model for continually compounded interest, use 17.86 years as your time, and you'll see that no matter what amount of money you start with, it will always triple in that amount of time.